Factoring. Factoring is used for simplifying rational expressions, solving for x-intercepts, graphing polynomials, and many more. The first step of factoring is identifying a factorable equation. The general form is ax squared plus bx plus c. This is the unfactored form, and note that it looks like a quadratic. The second step of factoring is simplifying. The idea behind factoring is to simplify. Our example is x squared plus 7x plus 12. Now how do we solve? First, let's show the unfactored form. This is our answer, x plus a and x plus b. That is a factored equation. Now how do we unfactor? We use the properties of FOIL and PEMDAS to unfactor. We use first, outside, inside, and last to multiply. We use our basic algebra skills to factor. So we have x plus a and x plus b. These are two expressions multiplied together. X times x is the first term. X times b is the outside. A times x is the inside. And note that these look alike. The inside, these are multiplying with the two inside terms. And then a times b is the last term. So x times x is x squared, a times x is ax, b times x is bx, and a times b is ab. And what we did was we used FOIL and PEMDAS. Now let's use some real numbers. Let's unfactor this equation. We have two expressions, x plus 4 and x plus 3. X times x is x squared, x times 3 is 3x, x times 4 is 4x, and 4 times 3 is 12. Now the 3x are common terms, so we can combine them to 7x. X squared plus 7x plus 12. That is our unfactored form, and x plus 4 times x plus 3 is our factored form. And we used FOIL to solve this. Now let's factor. We'll go from our equation x squared plus 7x plus 12 to the factored form. The factored form is multiplying two expressions, which is the simplest form. Now the first thing you want to do is insert x's as your placeholders for your first terms. The x times x equals x squared. The next thing you want to do is these two numbers that you're going to put into this equation, they have to be added to equal 7x. And then they have to be multiplied to equal 12. So 4 plus 3 equals 7, and 4 times 3 equals 12. That's how you know what numbers to choose. That's factoring. Now, there are many branches of factoring. Let's talk about difference of squares. Difference of squares is just a factoring made a little more complicated because there's no middle term. There's no bx. So let's factor x squared minus 4. We have x squared minus 4. Now the idea behind a difference of squares is we take our square, 4, and we use the positive and negative term and FOIL. So we have x plus 2 and x minus 2. This is going to equal x squared minus 4. Now let me show you why we don't have a middle term. We have x times x equals x squared. And then we have negative 2x and positive 2x and minus 4. The negative 2x and positive 2x cancel out, leaving us with just x squared minus 4. So difference of squares is one form of factoring. Another is completing the square. Completing the square is most often used when solving a quadratic. So our original equation is x squared plus 6x minus 7 equals 0. Now the first thing to do when completing the square is add your constant to both sides. So we're going to add 7 to both sides. We then get x squared plus 6x equals 7. Now, solving and completing the square, you take your coefficient on the x, don't forget the sign, divide it by 2, and then square it. 6 divided by 2 equals 3, 3 squared equals 9. Now what we want to do is add 9 to both sides. So we're going to get x squared plus 6x plus 9 equals 7 plus 9. Now we have to factor this left side of the equation. So we're going to do insert our x's, and in this case it's going to be x plus 3 times x plus 3 because this is a perfect square factor. On the right side we get 7 plus 9 equals 16. Now to simplify x plus 3 times x plus 3, just x plus 3 squared, and 7 plus 9 is 16. Now we have to solve. How do we get rid of the square? We use a square root. We're then going to have to cancel out the square root, and it's going to turn into x plus 3 equals 4. Now we don't know if it's positive or negative 4. Actually, it's both, so we have to remember to keep the positive and negative. Now we're going to solve for x. X equals negative 3 plus or minus 4. So x equals negative 3 minus 4, and x equals negative 3 plus 4, which gives us x equals negative 7, and x equals positive 1. We've just solved completing the square.